Yeah, so today we are here to find out to use the laws of vector addition to do something useful in physics. So first of all, this is a setup which I've designed so that I could explain it much better. Um, all the point charges, all the point charged particles for our imagination are 1 coulomb, plus 1 coulomb, and this one can be anything. Um, and the first question that would occur to our mind is how am I able to place point charges of 1 coulomb at at four corners in such a fixed position, whereas in reality they should repel each other. The thing is, um, we have we we have these charges kept at stationary positions because of an outer force applied on this. So it so happened that during the floods, the device that it generates the outer force, the force from outside, in such a way that these particles are remaining at rest, has been damaged. But then one of my devices is still there, and it's the it's the device that generates a charged particle. So, and it can generate a particle of any charge. I just want to find and I'm thinking that I can still manage to build this setup by finding out the amount of charge that should be that this particle should have, so that it would nullify the effect of the repulsive forces the four corner particles apply on each other. Let's start the experiment. We know that very well that the force applied by this charge will be like this, and then the force applied by this charge will be in this direction, and the other one I need not say. Now, let's say I want. Let's first find out the resultant force of these two. I mean these two corner particles, and that would be these two, and we'll apply triangle law. So I'll bring this force here just for the sake of imagination, easier imagination, and then low. Okay, so the net direction of the that and the other point charge, the charge particle, the net force applied by will be the same direction as the one at the corner. So that makes things easier. Now let's calculate it. Now we know, for our simplicity sake, we'll take this distance to be x. And by the way, this is a square setup, so, and this is the diagonal. So, and this distance will be x root 2, and this will be x by root 2. So now, how am I able to do it? First of all, the net force, by applying the triangle law, if if I take f to be equals to k by x square, k into 1 by x square to be f, then the net force applied on this by the other three particles will be uh, half plus root 2 f. And then I know that the and we know that the distance between this is x by root 2. So k into 1 into p, let's take the amount of charge on this to be q. Okay, k into 1 into q, kq by x by root 2 whole square will be x square by 2 will be k by x square is, we know, is f. So what we know is k by x square is f. So 2p will be equals to half plus root 2, and half plus I've actually done some rough calculations here, you can watch it. So the net force at the end will be this root the net charge will be equals to root 2 plus 4 by 4 root 2 coulombs. So that's the amount of charge that I need to put into this particle, so that I needn't apply any external force on the other four particles. And in that way, I have successfully conducted an experiment even during the times of flood. Thank you.